So far we've talked about how to graph an ellipse and how to transform it from the general form of a quadratic relation into the standard form of an ellipse, and how we find the center and how we have two radii, an x and a y radius. We're going to go a little bit more in depth with this video, and we're going to start by finding the location of these 2 points. These are the points. When we talked about the geometric definition, all points on the ellipse are equidistant. The sum from these 2 points is the same. So these points are called focal points or foci or foci. I'm not sure. I've heard it pronounced a lot of ways. I prefer foci. So the 2 foci, we're going to figure out how to find those first. So the formula that you need to use is kind of like the Pythagorean theorem. It looks similar to it, but we need to find this focal length C, and it's completely based on A and B. A being my x radius and B being my y radius. So C, which goes just out to the foci, the focal point, is going to be found using this equation right here, C squared equals A squared minus B squared. And the way I'm writing this formula implies that A is going to be the bigger number. A is not necessarily the number under x. It's not always the x radius. It's the major axis length, or half the major axis length. So whatever one's longer. But if you're using this formula and it turned out to be negative, you would just switch the order. Basically, I'm going to square my 2 radii, subtract them, and square root. So here's an example. This is a good example where A is actually the y radius, and this one is a radius that stretches vertically. It's a tall ellipse, not a short, wide ellipse. But it's, imagine its center is at negative 5, 2. Its x radius is 3 and its y radius is 5. So it kind of looks like, let's see if it's above or below. It kind of looks like this over here. Okay, but in this case, A is 5 and B is 3. But I want to find the focal points, the coordinates of the focal points. And C squared equals A squared minus B squared is my formula. C squared equals 25 minus 9. 25 minus 9 is 16, so C equals 4. Now, you have to remember to add and subtract from the center along the vertical axis in this case. The focal points lie on the major axis, the longer axis. So if it's a sideways ellipse like this, on the left, I'm going to go left and right of center. On this one, it's vertical, so I'm going to go positive and negative of center. So that center was at negative 5, 2. I just need to go up and down 4 spots from there. So my 2 foci are negative 5, 6. That's 4 spots above negative 5, 2. And negative 5, negative 2. That's 4 spots below. So our first in-depth ellipse topic is finding foci, and there's our first example. Our next topic about ellipses is what's called eccentricity or eccentricity. A lot of our terms have multiple pronunciations in this unit for some reason. I like eccentricity. The simple way to think of that is how squished it is. A circle that gets squished turns into an ellipse. And a circle, therefore, has not been squished at all. That would have an eccentricity of 0. Now, a circle that got squished so much that it turned into a flat line, this was really, technically this was an ellipse that just got squished and squished and squished until it became a flat line, that would have an eccentricity of 1. So all the real ellipses that are not circles or flat lines are going to be somewhere between 0 and 1, and this is the degree of squishedness. The formula that you need to have down is simple. It's C over A. C is the focal radius. We just talked about finding that on the last slide. And A is the semi-major axis, or it's the bigger of the 2, the x or the y radii, whichever one of those is biggest. So for this question, all I have to do to find eccentricity is take C, which we found on the last slide to be 4, and put it on top of A, which is 5, and we get 0.8 or 4/5. Okay, now that you know a couple characteristics, eccentricity and foci, we're going to use given info to write equations of ellipses. So this first one, here's what I'm telling you. Vertices are, they're going to be 8, 8, and negative 14, 8. And the foci are going to be negative 3 plus the square root of 21 and, comma 8, and negative 3 minus the square root of 21, comma 8. Now what you kind of want to do is kind of piece together what this graph looks like, and then you're going to use that equation for finding focal length to figure out either the A or the B, the parts that you're missing, and put all that together and fill in. Because really in our equation there's only so many numbers that need to get put in. I mean, I can tell the center real quick, which gives me 2 of the numbers in my equation. If the vertices are 8, 8, remember, vertices are the endpoints of the major axis, the longer of the two axes. Negative 14, 8 is over here. So here's a basic idea of what my ellipse looks like. I don't really know how squished it is, but I know that this is the longer axis. So I know that it's a sideways football shape just because the vertices are on the end of the longer axis. I can get the center right away. It's the point between negative 14 and positive 8, which, let's see, those are 22 apart, so it's 11, so that's negative 3. Right, I'm just finding the midpoint of negative 14 and 8, which happens at negative 3. So my center is negative 3, 8. So if I'm just working on my final answer, x plus 3 squared and y minus 8, negative 3 positive 8, squared. And I know it equals 1, so the only two things left are what are the x and the y radius. Well, again, the x radius is that 11 that I found a minute ago. So I can call this 11 squared. You could square it to make 121, whatever. The only thing left to find is what's the y radius. How, what this would be our b. How long is this b length? So the info that we know is basically the focal radius. It's the square root of 21 because the points negative 3 plus the square root of 21. And let's see, the square root of 21 is somewhere between 4 and 5, so that is going to get me into the first quadrant. Here's negative 3 plus the square root of 21, comma 8. Right, and I know you don't usually graph points like negative 3 plus the square root of 21, but we're leaving it exact. We're not rounding it off. It would be 1 point something if you rounded it off. But anyway, the other one, the other focal point, is there. What this is telling me is that the C length is the square root of 21. You can see this a lot because unless it's a Pythagorean triple, we're doing basically the Pythagorean theorem here except with a minus sign. So unless you're dealing with the right kind of numbers, you're going to get some square root numbers. But remember where that C came from. C squared equals A squared minus B squared, just like Pythagorean except with a minus sign. So C squared would be 21. A squared would be 121. Because remember, this is down here is A squared. So minus B squared. So that leaves B is 10. If I subtract 121, divide by a negative, square root 10 squared. So here's the equation of the ellipse with those vertices and those foci. All right, on this last example, the info that we're given is the location of the foci and the eccentricity. And if you're given the foci, remember those are along the major axis. So I know that this is a wide ellipse, not a tall one, because these points have to be on the longer axis. And I've got them kind of graphed in place. 2 plus 3 squared root of 5 is about 8.7, and this is about negative 4.7. Just so you can get an idea where they are. That doesn't really matter. You can kind of just plot them generically. But what I need to know is what's the middle of those two. And it's if one of them's 2 plus a number, one of them's 2 minus a number, then the middle is at 2,9. The center is at 2,9. So that gives me the majority of the numbers I need, well, at least half of them. My equation that I'm working on is going to be x minus 2 squared over something plus y minus 9 squared over something else equals 1. So I already know that much. I just have to figure out what are the x and the y radii. Okay, so the other information that I know is that the eccentricity, which is c over a, that's our formula for eccentricity, equals the square root of 5 over 3. Now, this can be a little tricky because this doesn't mean that c is the square root of 5 and a is 3, because if we had found eccentricity, we might have simplified that fraction to get the square root of 5 over 3. And actually, we can tell that the focal radius, this distance right here, from the information given, is 3 times the square root of 5. That's our c right there. So c over a is this ratio, but that came from 3 times the square root of 5 over 9. Okay, so if c is 3 times the square root of 5, then to make this fraction still have the same value, I need to multiply the top and the bottom by 3. So now I know my a value. My longer value is 9, so on the bottom of my answer, I'm going to write 9 squared. Or I could go ahead and make it 81. But now that I know that, there's just one more step left. C squared equals a squared minus b squared. So c squared is 3 times the square root of 5 squared, which is 9 times 5, which is 45. A squared is 81, which leaves b squared as 36. If I subtract, I'm going to move my b squared to the left. I'm going to do 81 minus 45 and get 36. So either b is 6 or b squared is 36. So I'm going to write it as 6 squared, and here's the equation. Okay, so there are 100 different sets of info that you can get, but basically what they all come back to is this. Eccentricity is c over a. Focal length is found using this formula. Put that together, act like a detective, you'll find the missing pieces.